Hello everyone, so in this video let us talk about the first question from the latest Lead Code Weekly Contest 392. So the problem statement is longest strictly increasing or strictly decreasing sub-array. As you can see in the problem statement, you are given an array of integers nums. You have to return the length of the longest sub-array. The sub-array means a continuous set of numbers. You have to find out a continuous set of numbers which are either strictly increasing or strictly decreasing. You have to find out the longest length of it. So you just have to check out for both the longest increasing and longest decreasing. You can check it easily. How you can check it? You can keep on increasing. Let's say you start out and finding out a strictly increasing. So strictly increasing means that the next one should always be greater than the previous one. So let's say you start your subarray from here. Okay, check that. Okay, 4 is greater than this, then that is fine. Now 3 is not greater than this, which means that this is a subarray. So which means that let's assume I'm not taking any numbers. But let's say you start from the first number. You check that it is strictly increasing, strictly increasing, strictly increasing. At this particular point, it is increasing. So how you can check that? You will check with the current number with the previous number. If the previous current number is greater than the previous number, then it is strictly increasing. You will keep on increasing. Now when you keep on increasing, at certain point it will keep on increasing the check. But at any point, let's say it doesn't match. Let's say at this point, now the next number is not greater than the previous number, which means that now this is a proper subarray which meets a condition. You can like maximize it for an answer, and then you again start out a new subarray from here, and you will again check out for increasing subarrays, and then you again start from here. So which means that wherever you find out a discontinuity, you will again make that value 0 and start counting from here itself. That is how you can find out a strictly increasing. Now strictly decreasing, you can do the same thing, but there's a catch. What you can do is that if you are finding out strictly increasing in this array, if you reverse this array, let's say the array become like this: 2, 3, 3, 4, 1. Then again, instead of finding out strictly decreasing, you can again in the reversed array find out strictly increasing only, which actually means strictly decreasing. Okay, so what I tried to say here is that instead of finding out strictly increasing and strictly decreasing, you can first find out strictly increasing, then reverse the array and use the same function to find out again strictly increasing in the reversed array. Because in the reversed array, strictly increasing means we are finding out strictly decreasing in the reversed array. You can check it out. So that is the overall thing. Because let's say if you find out strictly decreasing in this, strictly decreasing means that like this. So 4, 3. So 4 and 3 are strictly decreasing. Strictly decreasing in the left to right terms, if you move from right to left, it is strictly increasing. So which means that you can write down a common function of finding out strictly increasing numbers in an array. You can first check out strictly increasing, then reverse the array and use the same function to check out strictly decreasing. So that is how you can reuse the same code again and again instead of writing down the two logics in the same code, making it lengthy. I just want to tell you, that's why I've told you. You can also write it down strictly increasing, strictly decreasing, whatever you want. But I've reused the same code, that's why I've done this. So what I've done is that I have this particular function. Now this function has a check function. This check function check out whether it is strictly increasing. It will first check strictly increasing. It will store the answer what is the maximum strictly increasing subarray. Then you will reverse the array and you will again use this check function to again find out strictly increasing in the reverse array, which is equivalent to strictly decreasing. So now you have checked for strictly increasing and strictly decreasing, and you want to maximize it for both the answer and return the answer. Now how you will check out strictly increasing? You will have to first find out that there is always a case of maximum length equal to 1. Like a single element is always taken to be a strictly increasing. You can say that. Then you will make a count c equal to 1, which means that you have started s sub array at any point. Now you will keep on iterating over and check that the current number is greater than the previous number, which is strictly increasing. If it is strictly increasing, then you will keep on incrementing the count, which means that you are getting a sub array which is strictly increasing. So let's say you have started a count of 1 here, then you will get 1 here, then 2 here. So it means that it is strictly increasing. Okay, but else if you don't get this condition met, which means that now it is not strictly increasing, which means that you have to now start a count again from 1, because like now this is the first array in the subarray, second number in the subarray, and so on. Okay, so let's say the number is like this: 1, 4, 5, 6, 8. So you start from here, you will check that this is the first element in the subarray that is strictly increasing, then the second array because it is strictly increasing. Okay, so you will mark it 2, 3, 4, 5, which means that the length, this is the length of the subarray you are checking, that is strictly increasing. So that is how you will keep on incrementing C++, which means that you are finding out a element that is strictly increasing. Whenever you find out that this is not strictly increasing after 8, let's say it is 2, Then you will make your C equal to 1, which means that this subarray is done. Now you'll again start out a new subarray from index equal to 1, let's say 1, 2, and 3, and so on. Okay, and then after everything, you will maximize your count. Whatever the subarray you have seen till now, which is stored here, whatever the count, you will maximize it over all the subarrays you have seen till now, so that you will get the maximum increasing subarray. That's all the thing that you have to use here. Nothing much complicated. I have just used the same code so that this is a single code to find out a subarray in the increasing way. Then you have to write the same thing down for the decreasing way. But what we have done is a logic that we will just like reverse the array and then use the same code again and again 2 times and make the code reusable. Okay, that's the complete logic in the code part for this particular problem. It is just done in O of n, because even if you like reverse it, it is O of n. The iterating over is O of n, again iterating O of n, so it is 3 O of n, which is again equivalent to O of n only. And that's all logic in the code part for this particular problem. If you still have any doubts, you can mention on in the comment box for this particular video. I will see you in the next one. Keep coding and bye.